Lesson 9-2, Quadratics and Completing the Square. We can arrange a quadratic function in a way that will allow us to see the transformations that have occurred to the parent function. The rearranged function will be equivalent to the given function but will look different. So let's look at an example. Remember, our parent function is f of x is equal to x squared, and when we graph that, it looks like this. And we talked about transformations in the last lesson. This tells us 2 spaces to the left. This tells us 3 spaces down. And this tells us it has been stretched by a factor of 3. Okay, so if we go 2 spaces left and 3 spaces down, that moves our vertex to here. Let's do that in a different. Okay, so our vertex gets moved here. Now the stretching. What was once a 1, 1 is now a 1, 3. And it was once a 2, 4 is now a 2, 12. Well, we don't have quite enough. 11, 12 will be up here probably somewhere. So just do that. And our quadratic is going to be skinnier, moved over 2 spaces and down 3. So this vertex form gives us a lot of information where a traditional quadratic formula may not give us that much information. Completing the square is one of the first things we need to know in order to use the vertex form. And completing the square is the process of creating a perfect square trinomial to make solving a quadratic function easier. Now, if you remember, perfect square trinomials followed a very specific pattern, which made them very easy to factor. So the steps are, first we divide b by 2, then we square the resulting number, and that number is c. And so we're going to find the value of c in these functions. So we take b, we divide it by 2, that gives me a negative 2, and then we square it. So c would be 4. Here I'll take b, divide it by 2, and then I'll square that. So c would be 25. And now in this instance, I'm not going to get a perfect division, but that's okay. I can still square it. I'm squaring 3 over 2, so that gives me 9 over 4. So c is 9/4. And if I have negative 5 divided by 2, I get negative 5/2. And if I square negative 5/2, I get 25/4. So c is 25/4. Now don't be afraid of the fractions. We'll talk about how to work with those, but for right now we just found c. Now when we need to complete the square to solve a quadratic function, we have similar steps, but first we want to rearrange the quadratic so the x terms are isolated on one side. So I want to take this 11 and subtract it from both sides to get rid of it. So it'll give me x squared plus 10x is equal to negative 11. Then I divide b by 2. So I have 10 divided by 2 is 5. And then I square that number. 5 squared is 25. And I add that to both sides. So I'll have x squared plus 10x plus 25 is equal to negative 11 plus 25. So I'm going to go ahead and simplify. And then I'm going to factor the perfect square trinomial. This is my perfect square trinomial. And it will factor to where this number is equal to this number. Take the square root of each side. and I'll get x plus 5 is equal to plus or minus the square root of 14. Now to solve this, I'll subtract 5 from both sides. And since I can't combine a radical and a non-radical, I have negative 5 plus or minus the square root of 14. In order to combine these, I would need to simplify this square root. Okay, let's look at another example, or a few. Okay, we're going to solve the quadratics by completing the square. So first, I'm going to get the x's alone by adding 9 to both sides. Then I'm going to take negative 4 and divide it by 2. And then I'm going to square it. So I'm going to have x squared minus 4x plus 4 is equal to 9 plus 4. That's x minus 2 squared is equal to 13. Take the square root of both sides. X minus 2 is equal to plus or minus the square root of 13. Add 2 to both sides, and I get that x is equal to 2 plus or minus the square root of 13. Now, if I have a non-even b, this is not necessarily the best method for solving this, but we can still do it. I'm going to take 3 and I'm going to divide it by 2 and square it, and that's going to give me 9/4. So I'm going to add 9/4 to both sides. Now, in order to add this, I'm going to have to make this into fourths, so it's going to be 28/4. And I'm going to have x plus 3/2 squared is equal to negative 19/4. When I take the square root of both sides, I'm going to see that I created a problem that isn't going to work. I can't take the square root of a negative, so I'm going to have no solutions. Should make that no real solutions. Okay, so let's try this next one. We'll add 3 to both sides, and I'll have x squared minus 5x is equal to 3. Take half of negative 5, and I get negative 5/2. If I square that, that's 25/4. So that's what I'll add to both sides. Okay, 3 is the same thing as 12/4. So I'm just going to move that over here. So I'm going to have x minus 5/2. The sign will stay the same. Minus minus squared is equal to 25 plus 12 is 37/4. Taking the square root of both sides, I'm going to get, I'll move this up here actually. I'm going to get x minus 5/2 is equal to the square root of 37/4. Now, the square root of 4 is 2, and I can't leave fractions under the denominator, so I have the square root of 37 over 2. And when I add 5/2 to both sides, I'm going to get that x is equal to 5 plus the square root of 37 over 2. Now let's look at this one. When I add 69 to both sides, I'm going to have x squared plus 10x equals 69. Actually, I'm sorry, that was meant to be a 20x. I wanted this one to work out. So change that to 20. 20 divided by 2 is 10, and 10 squared is 100. So I'll have x squared plus 20x plus 100 is equal to 69 plus 100. So x plus 10 squared is equal to 169. Take the square root of both sides. I get x plus 10. Now 169 is a perfect square, so I'm going to have plus or minus 13. When I subtract 10 from both sides, I get x is equal to negative 10 plus or minus 13. That means x is equal to negative 10 plus 13 or negative 10 minus 13. That means x is equal to 3 or negative 23. I'll always get two answers, two solutions in a quadratic, unless I have one solution that repeats. Because remember, the solution is where we cross the x-axis. Now we use completing the square to put the quadratic function into vertex form. So here's how we do that. Oops, sorry about that. I take this equation and I only look at this part at first. So f of x is equal to, now I'm going to complete the square. So I'm going to take -4 and I'm going to divide it by 2, and that's going to give me -2. And then I'm going to take -2 and I'm going to square it, and it's going to give me 4. Now I'm going to add 4, but then I also have to subtract 4. And the reason I do that is because I have to add and subtract the same number, because that's the same thing as adding 0. And if I add 0, I didn't change anything. So I always have to add and subtract the same number. Now I'll take this and I will factor it into x minus 2 squared. And then I'll take this part and combine it. And now I'm in vertex form. I can see that I moved 2 spaces to the right and 13 spaces down. So let's try another couple of those. Okay, again we look at just this portion. 10 divided by 2 is 5, 5 squared is 25. So I x squared plus 10x. I add it and subtract it. Then I factor my perfect square. So I have x plus 5 squared, and then -25 and 11 is -14. So here I've moved 5 spaces left and 14 spaces down. Okay, trying this one. -5 divided by 2 squared is 25/4. So I will add 25/4 and subtract 25/4. So I have x minus 5/2 squared. And here I need to turn this 3 into fourths. So I have 25/4 minus 12/4. So it's going to give me -37/4. So I will have moved 5 half spaces to the right and down 37/4 spaces. Okay, our next, keep that as a 20. Our next function, we're going to divide by 2 and then square it. And then we'll add and subtract it. So I get x plus 3/2 squared minus, now remember this was, sorry, plus 9/4, and this is 28/4. So -9 plus 28 gives me 19/4. So I'll have moved left 3/2 and up 19/4. Now, as you can see, if I move up 19/4, I end up over here somewhere, and I'm not touching the x-axis anymore. Okay, we had our 20 divided by 2 is 10. 10 squared is 100. So I have x squared plus 20x plus 100 minus 100 minus 69. So I have x plus 10 squared minus 169. I'll have moved left 10, and down 169. So that's how we convert to vertex form when there's no coefficient on the squared, but then we have to do an extra couple steps when there is a coefficient on the squared. So a is not equal to 0. Okay, first we have to factor a out of the first two terms. Okay, so I factored the 3 out. Then I complete the square within the parentheses. Well, -2 divided by 2 is -1. -1 squared is 1. So I have x squared minus 2x plus 1. Now, I can't add 1 in here and not account for it also, but I'm not just adding 1, I'm adding 3 because this is 3 times 1. So I have to say 3 times 1, so then I subtract that. So I add 1 here, but that's really adding 3, so I subtract 3. So now I have 3 times x minus 1 squared plus 2. So let's try another couple of those. Okay, I'm going to factor out my 2. Now I'm going to complete the square. I've got this 3 here, so I need to take that 3 and divide it by 2, then square it. That's going to give me 9/4. Now just to see what that equals when I multiply it by 2, it'll be 9/2. So I'm going to add 9/4 inside the parentheses and subtract 9/2 outside of the parentheses. So this gives me 2 times x minus 3/2 squared. Now 10 is the same thing as 20/2, so 20 and -9 gives me 11/2. Sometimes when we divide, it doesn't divide evenly, which means we're going to get a fraction. So we just put 3/5 because we've divided 3 by 5. Now I need to take half of that. So 3/5 divided by 2 is the same as multiplying the denominator by 2, so I get 3/10. Now I need to square that, and I get 9/100. Well, now I'm not just adding 9/100, I'm adding 9/100 times 5. So that's going to give me 9/20 because 5 goes into 120 times. So I have to subtract 9/20, and then I have -8. 8 is the same thing as 160/20. So I have 5 times x plus 3 3/10 squared minus 169/20.